So far we've looked at two different types of hypothesis test examples, one where we looked at a less than situation and one where we looked at a more than situation. Both of them actually indicated that what I wanted to show was incorrect. So I wasn't able to say that less than 10% of people love the zoo but don't like pets, and I also wasn't able to say that more than 50% of people do not regularly floss their teeth. So I was incorrect on both accounts. This third example that we're looking at isn't going to have a direction connected to it, so it's a differs from problem. So when we look at this, we're going to start with highlighting the things that are important to us. So that includes how many people were sampled and how many successes we have. So we have 713 students who regularly wear sunglasses. We need to know what alpha is, so that helps us to make our decision down in step 4. We need to know what we would like to show, and today we want to see if it differs from, so the proportion of students who wear sunglasses regularly, if it differs from 60%, and then we need information on our parameter definition. So we're going to do proportions here of GVSU students, so that's our population, and a success is those who wear sunglasses. So we've already stated the population. Here our population is GVSU students. Our sample is 1,234 GV students. And then, as I've said before, this is not actually part of the textbook, but I like to add in my parameter definition so I can have an easy time writing my interpretation in step 5. So we're making an inference on P. Here we're saying proportion, so that's what's stated in the problem, of, and then we state our population, which is stated in letter A is GVSU students, and then we state our success, and we consider success if they say they regularly wear sunglasses. Okay, that would be the rest of step 1, and now moving to step 2, just like before, we write our null and alternative, so capital H sub O, capital H sub A, and then we're trying to make an inference on the parameter P, so we use the notation P here. And then remember, whatever is stated in the problem is what we want to show. So if you see language like differs from, less than, greater than, that's going to be the alternative. So here we want to show it differs from 60%. And like I've said in the past, you could use 60% in writing your null and alternative, but because I have to use the decimal value down here when I make my calculations, I prefer to just always keep it in its decimal format. So then the opposite of equals, or excuse me, not equals, is equals. So that would be our corresponding null. So we write differs because that's what's stated as our desire to show in the paragraph. So that's our alternative, and then we match the corresponding null to be the opposite of our alternative. So just like always, we state that the sampling distribution has a normal distribution, and to verify that, we do what's called checking conditions. So remember, checking conditions, you use n, so our n was said to be 1234 times p sub 0, which is the null value, and n times 1 minus p sub 0, or the null value, or what's stated in the hypotheses. Both have to be greater than or equal to 10. So we have 1234 times 0.6 and 1234 times 1 minus 0.6. So we have 740 and then 494. So because those both our conditions are met. And remember, all that means is that the normal distribution has been verified, and so therefore the formulas that we use are okay to use. So then we'll calculate our test statistic, which takes p hat And we have to calculate p hat, which remember is x divided by n. And here that's 713 divided by 1234. So p hat is equal to 0.5778. That would be plugged in, and then we have 0.6 as our null value, and then we use the null value in the calculation of standard error. So remember, I like to do the standard error calculation first, and I'm lazy, so I do each part. So that's the numerator of the null value. That's the denominator, so numerator divided by a sample size. And then I take the square root. So this is my null standard error. And I'm going to then use my test statistic numerator and put that in parentheses, and then divide by, I go second, and then that negative symbol to draw the answer, or what was in the row above. And that gives me a test statistic of negative 1.59. So because we have a z, down here we would have the normal distribution, just like before, as our answer for letter A. And then in B, we're centered at 0, so that's negative 1.59. I got a little far down there. And now, as we saw when we first looked at hypothesis testing, when you have an alternative that is a not equal to, it's called a two-tailed test. And so when you find the area, you actually go the area below the negative version of your test statistic, and then the area above the positive version of your test statistic, because essentially when you're saying that it's not equal, you're not sure if it's going to be less than or greater than. So because of that, you'll do both sides. So it maybe is not equal to 0.6 because it's less than 0.6, or maybe it's not equal to 0.6 because it's greater than 0.6. And so with that, you're doing two tails, or both versions, or both possibilities. So we'll just make it easy on ourselves, and we'll find each tail separately and then add them together. So still second and then vars, and because we have a z test statistic, we're using the normal CDF. And then here our lower bound is negative infinity, so we leave it as negative 999, but our upper bound here is going to be that negative 1.59. So we leave the 0 and 1 and go to paste. And we find then that the area here is approximately 0.06. So we're almost done. We've found one tail, now we have to find the top tail. So to do that, I'm just going to hide what we already did and just focus on finding what's here. So we're still going second and then vars. Again, normal CDF, but this time our lower bound is actually the positive 1.59. And technically our upper bound is going to be positive infinity, so we're going to change to positive 999. But again, we leave this as 0 and 1. So we go to paste, and this now is about 0.06. So our p-value then is the total highlighted area. So we have 0.06 for both sides of the tail. So I have a p-value of 0.12. So still asking the question then, with that p-value, is it less than or equal to alpha? And we have, so that again is not a true statement. So our decision then is fail to reject H sub O. So remember, when you fail to reject, you would start by saying there is insufficient evidence So that decision, failed to reject, moves us to insufficient evidence. And remember, step 5 is all about the alternative. So now I'll restate the alternative. So we defined P to be proportion, so there's insufficient evidence. The proportion of GV students who regularly wear sunglasses differs from 60%. So essentially all of the hypotheses that I had for this chapter I was incorrect on. So with the two-tailed test, it makes it a little bit more challenging because it might not be 60%, but because I didn't specify a direction, I can't say that it does differ from 60%. So it might be that it's less than, it might be that it's greater than, but the way the hypothesis test was stated, I was just looking for a difference, and I wasn't able to say that it differs from 60%, where I had the opportunity for it to be both less than or greater than for it to be different from 60%. So the next lecture we'll talk about what can go wrong with hypothesis testing, but now you've seen all three versions of a hypothesis test. Less than, greater than, and here we had a two-tailed test because we were looking at differs from.